Good morning, ladies and gentlemen, and welcome to Unit 9, Lesson 2, Part 2. Hopefully you watched Unit 9, Lesson 2, Part 1. So let's get to it. Please and thank you. Welcome, everyone. Yesterday, just to do a brief review of yesterday, Unit 9, Lesson 2, Part 1, we did talk about this definition, this formal definition of when two functions are inverses, and we know that the first function has to be one-to-one, has to be always increasing for the inverse to exist, always increasing or always decreasing. And we know that we had to restrict the domain of sine between negative pi over 2 and pi over 2 for the inverse to exist. And that's why we had this first statement here, this first equation with inverse sine of sine. And the formal definition, let's not forget this, the formal definition of two inverse functions is if you take the composite of the inverse and the function and get x, which is also equal to the function and the composite of the function and the inverse equals x as well. So that's a formal definition, and that's where these two statements here come from. And yesterday we did inverse sine. We talked about when it was defined and when it wasn't defined, and you can review yesterday's video to if you need to, you can review that. So today we're going to talk about the inverse of cosine. And before I talk about that, for this guy here to exist, we had to restrict the domain of cosine, and I'm going to look at how we did that. I'm going to go back to this slide, and I'm going to see that. I wonder if I can put him down on the bottom. Yeah, I can. I'll put him down here on the bottom out of the way. So I had to restrict the domain of cosine right here to be between 0 and pi. The range was still going to be between -1 and 1. And I'm doing this with the unit circle approach. I don't think I originally did. I did it more graphical approach of cosine x, but now I'm going to look at the unit circle because we're going to do the unit circle approach on some of these problems. So what I did is I restricted cosine for these angles between 0 and pi, right there, between 0 and pi. Therefore, and we know the output, the x values of the, golly gee, dude, the x values are going to be the outputs of cosine, the x values on the unit circle. And that tells me right here the range of cosine is between -1 and 1. The input of cosine we restricted from 0 to pi, this angle 0, and we went over all the way here to pi, and we encompassed the entire range of cosine by restricting from 0 to pi. And that tells me right away, because the domain becomes the range, and the range becomes the domain, that tells me the domain of the inverse cosine has to be between -1 and 1. And that's where, if I go back here, that's why this guy right here, I have two statements for this, for the inverse cosine statement. I have the cosine of inverse cosine is x, where x is between -1 and 1. We're going to look at that statement first, and then we're going to look at the second statement here in a bit, where the inverse cosine of cosine is x, but here x has to be between 0 and pi. So let's first foremost, let's just concentrate on this statement and do some examples of cosine of inverse cosine, the composition of cosine of inverse cosine. And all I do is I look at the input, and I check the input to see if it's between -1 and 1. Is 0.7 between -1 and 1? Indeed it is, so that's equal to 0.7. I come over here, same thing. I check the input. Is -0.3 between -1 and 1? It is indeed. So that's going to be -0.3. Over here, I'm checking -0.9. Is it indeed between -1 and 1? It is. So therefore, this is simply equal to -0.9, or I could go -0.9 if I wanted to. And now on this particular expression, cosine of inverse cosine of negative 1.5, what do I know? I know that negative 1.5 is not in that the domain of inverse cosine, so this is undefined. I'm going to say, hey, that is undefined. Okay? And hey, what are the above expressions not defined? It's going to be this guy right here, and I'm going to come up with a reason why, and the reason being is since negative 1.5 is not in domain of, let me get this guy up here. Now he's in my way. Put him right there. Is not in the domain of inverse cosine. Okay? And the other big important statement we want to make is this. If I take the cosine of inverse cosine is equal to x, where x is between negative 1 and 1, that's only defined. If x is outside of negative 1 and 1, this thing is not defined. Why? Because the domain of inverse cosine is strictly between negative 1 and 1. And what's going to get confusing is when I look at this statement right here, this second statement, inverse cosine of cosine, when I look at this. And so now all of these are going to deal with cosine, inverse cosine, sorry, of cosine of something. And although that's going to equal x, if what? If x is between 0 and pi. Okay? So let's check it out here. Let's see here. Inverse cosine of cosine pi over 3. I checked pi over 3. Is pi over 3 between 0 and pi? You betcha. So that's equal to 0. That's equal to pi over 3. Now I'm doing inverse cosine of cosine of negative pi over 4. Let's see. Ooh. Oh. Ooh. Ooh. I'm going to put a question mark on that. That's not negative pi over 3. The first thing I know, and I'm going to make the statement right here, that does not equal negative pi over 4. And so let's not make the mistake that that does equal negative pi over 4. It can't, because pi over 4 isn't between 0 and pi. But what I do know is this guy right here, true or false, and this is what's going to be kind of crazy. We do know that this cosine of negative pi over 4 is between negative 1 and 1. So this thing is defined. This is defined. It just doesn't equal negative pi over 4. And I'm going to do a graphical representation of how I figure out what that is, because we're going to do some other expressions that are not nice. This particular angle is nice, negative pi over 4. It's one of the nice ones on the unit circle. But so it is defined. It doesn't equal negative pi over 4, and we're going to jump down here and figure it out what it is graphically. But before I do that, let's go on here. Okay, so let's do inverse cosine of cosine. And I check, is 0 between pi over 0 and pi? It is. So that's simply equal to 0. And let's, is 4/3 pi between 0 and pi? It is not, so this does not equal 4/3 pi, and it doesn't equal 4/3 pi because 4/3 pi is not between 0 and pi. But it is indeed defined. It is defined, so I'm going to do both of these on the unit circle down here. It is defined. I'm going to do both of these expressions here. I'm going to give the graphical representation of both of these expressions and how you find them on this unit circle down here. Okay? And so I'm going to do this guy here first. And the first thing I'm going to do is I'm going to look at this dude right here. I'm going to look at the cosine of negative pi over 4. Well, negative pi over 4, I already have this angle sketched. This is negative pi over 4. Oh, so it's going to map to this point right here. This is a unit circle graphical representation. And this is what we want you to get used to doing. And so what is that? Oh, I know that right there is going to be square root of 2 over 2. That's that x value right there. This is square root of 2 over 2. So what I really want then, I want to know what this is. Square root of 2 over 2. And I know that from Unit 9, Lesson 1, I know what that is. But if I want to do my graphical representation, all I need to do, I'm going to come over here and I'm going to sketch this yellow vertical line right here. And I'm going to label this point right here square root of 2 over 2. And so what I need is the angle that maps to that. Oh, let's do a funky green color angle. And what is the angle that maps to that? Well, that angle is pi over 4. So this guy right here is pi over 4, and we knew that from the last unit as well, lesson 1, the unit 9, lesson 1. So this guy here doesn't equal negative pi over 4. This is equal to pi over 4. So let's, on the same sketch here, let's do this dude right here. On this same unit circle, I think we have enough time. We'll certainly have enough time. I think we have enough space to do this guy right here. Because you're going to be asked to do some graphical representations of what this means. First of all, I do know this thing is defined, but it does not equal 4/3 pi, because 4/3 pi is not in this from 0 to pi. So what I'm going to do is I'm going to sketch a line over here. I want 4/3, 1/3, 2/3, 3/3, about 4/3 right here. This angle is 4/3 pi. There's my 4/3 pi. What is that x value? That x value associated with this is going to be negative 1/2. And I do know that. I do know that the cosine of 4/3 pi is equal to negative 1/2. Well, in like manner, the same way I did over here, I'm going to sketch this vertical line here. And you're going to see this is going to seem easy when you have nice angle values. But I'm going to do an example. I'm going to need to pull that line over just a little bit. And what do I want? I want the angle between 0 and pi that maps to this guy right here, this x value of negative 1/2. And what is that angle? Let's do this funky right here. What is that angle? Let's start here. That angle right there is 1/3, 2/3. So this guy here is 2/3 pi. 1/3, 2/3. Because cosine of 4/3 is the same as the cosine of 2/3. And the cosine and 2/3 is between 0 and pi. So now I'm good, because this guy right here is indeed 2/3 pi, is indeed between 0 and pi. So those are all angles that we knew. So let's do another example here of an angle that we don't know. And then we're going to close this video out. So I'm going to do a graphical representation. This is going to be my last example here. I'm going to close this video. Let's see here. I want the inverse cosine of 9/8 pi. Well, the first thing I need to realize is that this guy here, cosine, step number 1, this did not equal 9/8 pi. It does not equal 9/8 pi, since 9/8 pi is greater than pi. i.e. 9/8 pi is not between 0 and pi. What I do know is this guy right here, cosine 9/8 pi, is indeed between -1 and 1, because the cosine of anything is between -1 and 1. So what I want to do is figure out what that is. And hopefully a lot of you can see what that is. But what we want here is we want this graphical representation, which is going to be important down the road. We want this graphical representation. Okay, so what I'm going to do is I want to find this 9/8 pi. I want to find this angle 9/8 pi. Let's see here. Where's that 9/8 pi going to be? Well, it's going to be greater than pi. It's just going to be a little bit, hey, let's just put that rascal right there, and that would be about right. That angle right there is about 9/8 pi. And at this point, I really don't know. And if I go back to these examples, this example here, to figure out what these were, did I really need to know that the cosine of negative pi over 4 was square root of 2 over 2? Not really. Did I really need to know that the cosine of 4/3 pi was -1/2? Not really. I just needed to know where the angle terminated, which was between 0 and pi. Let that sink in a minute, and that's what we're going to do here. What we're going to do here is we don't really know what this is. I mean, we could use our calculator, but we're not going to. But we really don't know what this is, this guy right here, this cosine of 9/8 pi. You know what I'm going to do? I'm just going to give it a name. I'm going to call it, I don't know, let's call it B. Let's call that x value B. And we know this angle here is 9/8 pi. So what I want is an angle that maps to this x value. And I know here that B is negative. B is less than -1 and between 0. I know that. So let's go over here and find this. Let me change my other angle. Let's change my angle to orange colored angle. And you tell me, I'm going to stop that rascal when I have the same B value. And that would be about, oh, looks like that's about right there. And this angle right here, ladies and gentlemen, that angle is indeed between 0 and pi, and that angle does indeed, if I do this yellow vertical line here, have the same output as the cosine of 9/8 pi. So this is going to be B. So all I really need to do is to figure out what this angle is here. How do I do that? Well, I'm going to look at this angle right here. What is this angle right here? Well, it's going to be pi plus 1/8. Isn't this angle right here, that little green angle, 1/8 pi? Yes. So therefore, this angle that we want, this blue angle, call it whatever you want to call it. Let's call this angle Z, if you will. What is the angle Z? Z is going to equal pi minus 1/8, because that's going to be, these angles are going to have to be congruent because of congruent triangles. They're both going to have the same hypotenuse. They're both going to be right, and they're both going to have the same leg here. This is the triangle that I'm looking at right here. I'm looking at this triangle here, and I'm looking at this triangle here. So these angles have to be congruent, and they're both 1/8. So if I want to find Z, Z is simply pi minus 1/8. Well, what's pi minus 1/8? You betcha. It's 7/8. Therefore, this guy here, this Z, is 7/8 pi. What do I know then? There I go. Therefore, this is equal to 7/8 pi. So you might have to rewatch this video. A little bit tough, but that's okay. I think you can do it. You definitely want to fill your notes out. You're going to have an assignment similar to a problem like this, and similar to some of these problems like this as well. Problems like this and problems like this, you'll have an assignment over that. I think the Google form is similar to these problems here, and similar to these problems here, the Google form is. Okay, so I might have to read it a couple times, and we're going to continue this discussion tomorrow when we do Unit 9, Lesson 2 activity. So I bid you good day, and see you soon.